Good afternoon, Algebra 2. Yesterday we talked about logs and how they are the opposite of exponential equations. And so today we're going to talk about some things that you can actually do with logs. So just like there are rules of what you can do with exponents, there are rules of what you can do with logs. And these ones are actually kind of fun. So if you look here, I've got this nice little chart. The logs of logarithmics. If you've got a plus sign between two logs, it's the same as taking a log, and mind you, the base has to be the same for all these. But if you have the addition between them, you can actually take them, put them on the inside of the log, and multiply them. So that's kind of fun. And they're versus too. So if it's being multiplied, you can take them apart and write them out as addition. If there is a subtraction between the two logs, you can actually take the components and you can actually create a quotient or a division thing with it. So it says log base a of m minus log base a of n. You just take m and you divide it by n. If you have an exponent on inside your log, you can actually take that exponent and stick it out in front, which is kind of interesting. That's the third law, and they call it the power rule. Also, if you have the log base a of something that's a to k, that log base a and the base a cancel out, leaving just k behind. That one's very useful when we're trying to eliminate logs. And then the last one, they call it the zero rule. Log base a of 1 is 0. Log base anything of 1 will always be 0. Just like we said, exponent, anything to the exponent of 0 is 1. It comes from the same rule. So these ones are going to be very useful in our lesson today. With that in mind, I'll slide down here to the assignment on 7-4. So, for example 1, and for 1, 2, and 3, they want us to apply these rules that we have. So I'm going to take the first one. The first one, let me zoom in a little bit. It's log 5 of 50 plus log 5 of 625. Okay. So, number 1. Now, just like before, when I had the plus sign, I can end up multiplying them together. That's what I'm going to do for this first one. Oops, the wrong button. Okay, so I have log. I don't know why I always want to leave out the O in my log. All right, so log 50 plus log 5 of 62.5. This actually becomes equals log 50 times log 62.5. Okay, so it's going to look like that. Pull up my calculator. It's not cooperating. Give me just a second. Okay. Aha, got it. All right, so 50 times 62.5 is going to give me 3,125. Now, there's something to keep in mind. Since I have log base 5, I probably can factor that 3,125 by 5s. So if I do it by 5, I get 5 and 625. Do it by 25, I've got 25 and 125. So see, if I do 25 gives me 125. This is going to give me a 5 and a 5. 1, 2, 5 is 5 and 25 again. So that's 5 and 5. So I have 1, 2, 3, 4, 5 of these. So 5 to the 5 will give me 3,125. So I say, okay, log base 5, 5 to the 5. Now, if you remember the rule we had up here, anytime I have a log base 5 with the exponent of 5, sorry, not exponent, with the same base of 5, all I am left with is the exponent. Oh, that's a mouthful. So in this case, the log 5 and the base 5 cancel out, and now all I'm left with is just 5. So, believe it or not, everything written down there for 1 just is 5, which is kind of nice. Nice and simple. Well, maybe not simple, but the answer is simple. Let me do one more. Let's see. Second one's pretty easy. Third one looks like it'd be a little bit more of a challenge only because it has 3's involved in it. So, yes, log 3 of 3. Number 3 seems appropriate for number 3, oddly enough. Let me shift this down. Okay, so I have log. I have log 3 of 3 plus log 3 of 27, which is the same as saying log base 3 of 3 times 27. Now, normally I'd multiply this together like what I did above, but I'm going to take advantage of the fact that I know that 27 is 3 times 9. And that 9 is 3 times 3 to help me factor this thing. Try that again. Okay. So I have log base 3 of, and then the 27 is 1, 2, 3 threes, and so the other 3, that's 3 to the 4. Okay, so log base 3 of 3 to the 4th, the 3 and the log base 3 cancel, and all I'm left with is simply 4. As you can see, it's not hard, it's just a matter of doing. So that leaves you with number 2. Let me go to example 2. Express as a single logarithmic. Simplify if possible. So just like before, I was adding, this time I am subtracting. I'll slide this down just a hair. Okay. Let's do number 5. It has the decimal. I've got log. Now this log doesn't have a number written under it. It's understood to be log base 10. 10 is the standard, and that's the one that your calculators will use. And they don't write it in. It's one of the few times that you actually have an divisible 10 in math. But it's right here with the log, so just be aware of that. It's actually log base 10. You just can't see it. So log base 10 of 5.4, oops, subtracting log base 10 of 0.054. It's a 4, not a 9. Thank you. Try that again. Okay, 4. Yeah, that looks better. All right, so since this is subtraction, it means I'm going to take my 5.4, and divide by my 0.054. All right, right, 5.4 divided by 0.054. Typed in wrong. Try that again. 0.4 divided by 0.54. That's going to be 100. Oh, duh. I could have looked at that and just seen it rather than putting it in the calculator. One of those days. All right, log of 100. Now, mind you, log is base 10. 100 I can put into a form of 10. In fact, I'll write 10 in here. 100 is just 10 to the 2. There we go. So there again, log base 10, 10 cancels. All I'm left with is simply a 2. So this isn't hard, it's just a matter of doing simplification. All right, let me jump to example 3. They want us to simplify if possible. Now, just like we've been doing with everything else so far, I want to be able to factor something so that it has the same base on the with the exponent that I have with the log base. So that's the trick to these. Sliding down. Okay, so let's take ten is a yucky one. So let me do 10. All right, 10, I have log base 1/2 of 0.25. And they give me an exponent of 4. I'm going to draw a line in here to keep these guys separate. Okay, so I'm going to rewrite this. Now, remember, I can rearrange these things into exponent form. If I did that, it would be 1/2. I don't know what my answer is, equals. And then I have 1/4. You know what? That's not the approach to take. Let me try it this direction instead. I'm going to take my 0.25 and I'm going to put it into a fraction of 1/4. That would be the easier way to go. So log base 1/2 is 1/, now 0.25 is 1/4 to the 4. I can rewrite 1/4 in terms of 1/2. And the way I do that is I know that I multiply 2 by 2, so I square it to get 4. So all I have to say is, okay, log of 1/2 is going to be 1/2. And then I'm going to square that, and then I'll put the 4 on the outside like this. Okay? Now with that in mind, I'm going to now I have log base 2 of 2. Let me multiply the 2 and 4 together before I do anything else. So I have log of 1/2. 1/2 to the 2 times 4 is 8. Now if you look, the log 1/2 and half, that will cancel out and give me an 8. Okay? So that will work better. So that was 10. Like I said, 10's a little ugh. Let's do, let's see, looking. 11's easy. Those just cancel straight up. You just have x over 2 plus 5, so that one doesn't look nearly as bad. 12 also cancels straight out, and all you're left with is 19. I guess the other one that looks like it would be hard would be 14. Yeah, 14 is going to be difficult. 13 is a little difficult. All you have to do, though, is factor your 1024 in terms of fours, and then that actually becomes becomes very simple to do. Let me put it that way. All right, so let me do number 14. 14 is log base 2 of 1/2 to the 4th. Okay. So I have log base 2 of 0. Sure, I wrote that down. Is it 0.5? Yes, 0.5 to the 4. All right. Now, let me rewrite this. Log base 2. And then if I write 1/2 for 0.5, automatically you can see there's a 2 here, a 2 there. Difference between that, the only way I can make that 1/2 into a 2 is 2 to the negative 1. So let me do that. Log base 2 of 2 to the negative 1 to the 4th. There again, I'm going to multiply my exponents together. Log base 2, 2 to the negative 4. All right. Now the log 2 and the base 2 are going to cancel, leaving me simply with negative 4. Okay. So those are the two, the nastiest from that section. Let's do something from example 5. So I've got, let's see what we got. I have log 9 of 1/9. That's actually probably going to be the nastiest one I have here. Let's do that one first. I am going to erase a little bit of this so I don't have to go all the way down. Give us some working space. Okay. So number 15. And this will be the hardest one of this set, but you'll get the idea. There again, I'm trying to get it so it has the same base with an exponent that the log has. So I have log of 3 of 1/27. Now 27 in terms of 3 is going to be 3 to the 3rd. But since it's in the denominator, it needs to become negative 3. All right, so it's 3 to the negative 3. The negative will make it flip to the bottom, and 3 to the 3 is 27. So I'll take care of that. And now, of course, it's just straightforward. Log 3, base 3 cancel, and you just end up with literally negative 3. So as you can see, this lesson's not too bad at all. You guys don't have to worry about number 19. Not an issue. So just do from 1 to 18. And we've done 1, 2, 3, 4, 5, 6 of them already. So please don't hesitate to let me know if you have any questions on this. If you need any extra help, you can reach out to me either by phone or email. Probably phone's better because I don't check my email all the time, but my phone is here. Anyway, I hope you have a great day at home, and hopefully I will see you guys tomorrow in class.